Good morning, everyone. I'm Dikshita and my friend Kachani are here to present our project, an analytical model to identify cervical conditions using digital colposcopy images and convolutional neural network algorithms. This project was completed under the valuable guidance of Dr. M. Suleiman Basha sir, Associate Professor of the Department Computer Science Engineering Data Science at RGM CET. In this presentation, we'll walk you through how we built a deep learning based diagnostic model that uses colposcopy images and CNN algorithms to automatically detect and classify different stages of cervical conditions. Our aim is to provide an intelligent, fast, and reliable system that assists healthcare professionals in early detection of cervical diseases, which is key to reducing mortality rates. Cervical cancer is a major health concern for women worldwide, and early detection is critical for saving lives. Traditional methods for diagnosing often miss early signs due to limitations in medical equipment and human interpretation. In this project, we propose a deep learning based predictive model that uses digital colposcopy images and CNN algorithms to detect various cervical conditions including precancerous and cancerous stages. Our system improves detection accuracy, reduces manual effort, and supports healthcare professionals with fast automated screening. Let's dive into intro of cervical cancer. Cervical cancer begins in the cervix and is usually caused by human papilloma virus or HPV. It can be prevented through vaccination and early screening, but the current methods like pap smears and colposcopy are limited in their ability to detect the early stage diseases. Our goal is to create a deep learning model that uses colposcopy images to accurately identify the cervical conditions and assist doctors in early diagnosis. Let's discuss the objectives of our project. The objectives of our project are to build a deep learning model that detects and classifies cervical diseases to overcome the challenges in traditional detection methods like equipment dependency and human error. To provide a more accurate and automated diagnosis system, and finally to evaluate our model using four metrics like accuracy, precision, recall, and F1 score. Now I'll move on to the literature review section of my presentation. This part focuses on previous research studies and existing work related to our topic, which is an analytical model to identify cervical conditions using digital colposcopy images and convolutional neural network algorithms. The purpose of this review is to understand what methods and models have been already used in the field of cervical disease detection, what challenges have been identified, and how our approach adds values or improves upon them. I now explain the key studies, techniques, and findings that form the foundation of our proposed work. Let's consider the application of efficient net BO and GRU based deep learning on classifying the colposcopy diagnosis of precancerous cervical lesions. In this, the researchers collected the 6,002 colposcopy images, and they used hybrid deep learning model combining efficient NetBO and GRU, that is gated recurrent unit. In this model, they used this as optimized for image classification, and GRU is used as a type of recurrent neural network that is effective for handling sequential data. This hybrid model was trained to distinguish between high grade squamous intraepithelial lesions versus normal low grade squamous intraepithelial lesions. And they found that AI can assist in early detection of cervical lesions with high accuracy. It was particularly good at distinguishing three serious cases from less serious or normal cases, performing reliable classification into three categories for clinical decision making. The model performance depends on the generalizability and image quality. The need for further clinical validation to ensure safety and effectiveness before real world use. Next, we'll we'll see the existing methods of existing methods of this existing methods of cervical screening methods such as pap smear, colposcopy, HPV testing. Pap smear, which is inexpensive but may be subjective results have and subjective but may be give subjective results and has sampling errors. Colposcopy, which gives a detailed view but suffers from the limited accessibility. HPV testing, high accurate for HPV detection but limited in predicting disease progression. These limitations motivated us to explore deep learning as a powerful tool for improving detection accuracy and speed. In the current system, diagnosis is done manually by doctors using pap smears and visual examination. These methods are often slow, error prone, and requirement expert interpretation. Because of this, early stage conditions might be missed, leading to the late treatment and higher risk. So, we need more reliable automated system, and that we propose. Pap smear. It is also known as Papina color test. A healthcare provider collects the cells from the cervix using a small brush or spatula. These cells are then examined under the microscope to detect abnormal changes such as precancerous or cancerous cells. These are these are widely used and accessible, effective at early detection of precancerous lesions, cost effective for managing screen, and they may be miss abnormal cells, require skilled cytologists, less effective in detecting adenocarcinoma compared to squamous cell carcinoma. Colposcopy. It is a visual diagnostic procedure which the cervix is examined using colposcope. If the abnormalities are observed, the doctor may take a biopsy, a small tissue sample, for further analysis. It provides a closer and more detailed view of cervix, allows for targeted biopsy improving diagnostic accuracy, often used after an abnormal pap smear result. Cons. Invasive and may cause discomfort or bleeding during biopsy. Requires trained specialist and equipment. Subjective. It is a subjective. Depends on the clinical experience and judgment. HPV testing, a test for the presence of high-risk strains of human papilloma virus, which is leading cause of cervical cancer. It can be done using same sample as pap smear or separately. It is high sensitive because it is better at identifying women at risk compared to pap smear alone, and can be used for primary screening or in combination with pap test, and detects infection before cellular changes occurs. But it may defect infections that are temporary and resolve naturally, leading to unnecessary anxiety or procedures. It is more expensive than pap smear alone, not always available in low resource settings. Let's Let's continue with proposed system. We developed a CNN-based model that analyzes colposcopy images and classifies cervical conditions. This model learns from thousands of medical images and automatically detects signs of disease. The benefits are better accuracy by detecting subtle indicators, early stage identification, reduced efforts for doctor through automation. And the next topic will be continued by my teammate Kachani. And I
Now let us learn about system architecture. System architecture refers to the structured framework that defines how different components of a system interact, work together, and flow from start to end to achieve a specific goal. In context of our project, system architecture describes the entire process or pipeline used to collect and prepare the image data, train the deep learning models, evaluate the models, and use the best model to detect cervical diseases. Some of them are: we experimented with several deep learning models like efficient net B0, a lightweight scalable network from Google AI. It was introduced in the year 2019 with key features like lightweight, scalable, high performance convolutional neural network. Next is BGG16. BGG16 is a 16-layer deep convolutional neural network designed for image recognition and classification. It was published in the year 2014 in the paper Very Deep Convolutional Neural Networks for Large Scale image recognition. ResNet 50 introduces residual connections for better training. It was developed by Microsoft Research. In, it was published in the year 2015 in the paper Deep Residual Learning for Image Recognition. VGG19 is a 19-layer deep. It was published in the year 2000. VGG19 కి తను మ్యాటర్ తీయలేదు.
మరి నువ్వు ఎందుకు VGG19 తీసి ఆడ ఉంది కదా పీపీటీలో?
నేను చెప్పినా ఇక్కడ VGG19 తీసేసినావా అని. System architecture refers to the structured framework that defines how different components of a system interact, work together, and flow from start to end to achieve a specific goal. In context to our project, system architecture describes the entire process or pipeline used to collect and prepare the image data, train the deep learning models, evaluate the models, and use the best model to detect cervical diseases. We experimented with several deep learning models like Efficient Net B0. It is a lightweight scalable network from Google AI. It was introduced in the year 2019. VGG16. VGG16 is a 16-layer deep convolutional neural network designed for image recognition and classification with key concepts like 16 layers deep and uses 3x3 convolutional filters, fixed architecture efficient for image classification. ResNet 50. It introduces residual connections for better training, developed by Microsoft Research, published in the year 2015 in the paper Deep Residual Learning for Image Recognition. DenseNet is a type of convolutional neural network architecture where each layer is directly connected to every other layer in a feed-forward manner. Inception v3. It was designed by Google, known for efficient architecture. Exception. It uses depth-wise separable convolutions and performed best in our testing. We used a large balanced dataset of digital colposcopy images. Each image was labeled with correct diagnosis, making it suitable for supervised learning. It helped the CNN model patterns associated with different disease stages. Our workflow involves 5 steps. Data collection is the stage where we collected thousands of colposcopy images with labels. Data pre-processing. Images were resized, normalized, and augmented. Model training. CNNs were trained on the pre-processed data. Model evaluation. Accuracy, precision, recall, and F1 score were used to assess performance. Model deployment. The best model was deployed to analyze real-time colposcopy images. For software, we used Anaconda as environment setup, Python as a core programming language, Jupyter Notebook for backend development, React and Tailwind CSS for front-end design, SQLite 3 and MongoDB to store and manage data. Hardware specifications for training and deployment model include Windows 10 or higher versions, at least 25 GB of hard disk, and for cloud deployment we used AWS SageMaker with the ml.g5.xl large instance. We tested our model using 4 key metrics: accuracy, overall correctness or of predictions, precision, percentage of correct positive predictions, recall, how many real positives were correctly predicted. F1 score combines the precision and recall into a single value. Among all models tested, Exception achieved the best results, showing over 96% accuracy. We referred to multiple research papers to build, evaluate, and validate our model, including papers on deep learning models in cervical cancer detection and CNN classification using Fisher's code. These studies help to shape our model and evaluation process. That concludes our presentation. Thank you for your attention. We are happy to answer any questions you may have.